Hi guys, I am Dr. Nandabalaji. Today we are discuss about the topic of crystal structures, introductions of crystals. First of all, recall the structures like as physical structures of gaseous state, liquid state, and solid state. In a crystal structure, it's a unique arrangements of atoms or molecules in a crystalline materials governing in physical properties. We are discuss about the topic of introductions of crystals, crystalline and non-crystalline solids, and why we need single crystals and real-time world applications. First of all, why we need single crystal. First, we are understanding the fundamental properties of crystal structures and their types is essential for advancing material science. Each crystal type plays a virtual role in various applications, driving innovation in technology and enhancing performance in numerous fields. In these crystals, like as solids, are classified in different manners. In this, solid materials are defined in two different types of material. One is crystalline structure, another one is non-crystalline structure, like as amorphous. In crystalline structures defined as two different line, like as single crystals and polycrystals. First of all, we explore the crystalline solids. In the structure, in the diagram of structures, crystalline silicon dioxide, like a quartz system, the arrangements of atoms are very neat and shape. So that's why we are saying the crystalline solids arrangements of unit of matter is regular and periodic. Anisotropic substance and sharp melting point possess a regular shape like as the examples of iron, copper, carbon, germanium, and crystallines of SiO2. These are the crystalline solids. And what is non-crystalline solids? In this diagram shows the non-crystalline single silicon dioxides. In this arrangements are randomly arranged and randomly s- fixed. So this is amorphous solids. Particles are randomly distributed, and this is isotropic substances have wide range of melting points. Examples of glass, plastic, rubber, etc. And the explorers of polycrystalline solids. The figure shows the polycrystalline solid structure view. In this structure gives a aggregate of many small single crystals, high degree of order over many atomic or molecular dimensions. Grain boundaries and grains are usually 100 nanometer to 100 microns in diameter. Polycrystals with grains less than 10 nanometer in diameter are nanocrystalline. Examples of inorganic solids, most of the metal and ceramics are the polycrystalline solids. And what is crystal structure? So first of all, we know the crystal structure is equal to lattice point and basis points. The combinations of lattice and basis it's used as the crystal structure. In the diagram shows the lattice points and basis point crystal structures diagram. A unit assembly of atoms or molecules identically in composition based on arrangement and orientation. Repetition of basis correct periodicity in all directions. The crystal structure is real while the lattice is imaginary. Applications of crystals in real-time world like as different types of applications we have. Memory devices, sensors and actuators, fuel cells, catalysts, solid state refrigerators, solar cells, and electronic devices. These are the real time applications the crystals are used. The crystalline structures of solids are classified into two different structures. One is crystalline structure, and another one is non-crystalline structure. In these crystalline structures, we have splitted into two different types, like as single crystals and polycrystals. In the single crystals, based on crystal systems of seven types, like as cubic structure, tetragonal structure, orthorhombic structure, hexagonal structure, rhombohedral structure. Based on polycrystal structures have a bonding structures like as ionic bonding, covalent bonding, metallic bonding, and molecular bonding structures. In non-crystalline structures, amorphous solids has no sharp melting points, irregular arrangements of atoms, like as example of glass, plastic materials. Assessments in the single crystals, it's a random arrangements, like in these arrangements of crystals, polycrystals, amorphous, we are using in daily routine places, like as salt as a crystal material, and carbon as a crystal material, and diamond as a crystal material. These type of crystals are on the materials, crystal materials. Thank you guys, thank you.